folks, today we are starting a new project. It's called autonomous vehicle or a self-guided vehicle. This is my son Mokshim. He is in 7th grade. I am a software professional, and we both are collaborating on this project. What we are doing is we will want to convert a RC car in a self-guided car, and we saw a lot of videos on YouTube and internet to understand how other people have done, and based on what we learned on the internet, we are now planning to do it slightly different in our own way. So first thing what we learned is that people have used very small remote control cars, and the problem with them is that then everything kind of gets on top of the car, which looks very ugly. So we have brought ourselves two RC cars here, which we think are large enough so that all the electronics that we will put inside this car will actually go inside, and then we can have a nice top to cover it all, and we don't basically end up in a very ugly looking car. And so when we went to shop for a remote control car, we had two options. One is this Hummer, which I think is 1:10 scale. It's quite big. It's about 1.5 feet long. And the other option for us was to go for, move this back. The other option was to get something like this, which is a more sporty kind of a car.
It's a buggy.
It's called a buggy. The problem with this buggy is that it doesn't have space here, but it has got a better suspension, and apparently it has got more speed as well as compared to the Hummer. But somehow I like Hummer because it has got a lot of void space inside where we can put all our electronics. This buggy actually doesn't have a lot of space, so if we start building a car on this, we will most likely fall short of the space, and then we will have to get rid of this cover, and then everything will start showing up. So this is one of the reasons why we have chosen this Hummer as our platform vehicle for the project. Another thing to consider while purchasing the remote control car is that there are a lot of variations available. So there are remote control cars which have these kind of remote controls. They basically operate at 27 megahertz frequency. This is a kind of a very old technology. And some of these remotes also have channel A, B, C. Some don't. So for example, the one for this buggy doesn't have channel, just one channel, whereas the one for this Hummer has 3 channels. But in this project, we will most likely lose the remote because it will be redundant for us. Maybe we will replace it with a software-based remote control. So right now, the frequency of the RC vehicle is not important from this perspective. However, what is important to note while buying a remote control car is that there are remote control cars, one which have a brushed DC motor, and the latest ones have the brushless DC motors. So a brushed DC motor is an old DC motor which doesn't have a lot of power as compared to a brushless DC motor. However, in silo, even the brushed DC motor is quite powerful, but if you compare it to a brushless DC motor, it's not as powerful and maybe not as fast. When we tried this vehicle which has a brushed DC motor, it goes quite fast. In fact, on the package it is written that it can go up to how much kilometers per hour?
180 kilometers.
Up to 180 kilometers per hour. But I think it won't go that fast, and we don't even need that kind of a speed. But when we did some tests last night, we found that it's quite fast. The problem with both of these vehicles is that they don't have any speed control on these remotes. So we will have to do a bit more engineering to tame the speed of these vehicles. Uh, so for example, when we push the forward button, it basically drives the vehicle at one speed, and when we push the reverse button again, it basically drives the vehicle at one speed. What we would want in our project is to also the ability to control the speed of the vehicle, and based on our research, it is possible to control the speed of a DC motor also, and of course it is also possible to control the speed of the brushless DC motor. So for this project, we have a brush DC motor, and another thing that we will need in this project is a camera which will go either on top of the vehicle, but of course again it spoils the look. So what we will do during the process is we will kind of fit it inside the vehicle somewhere. So we have a lot of options here because there is plenty of space. So we will hide this camera somewhere inside the vehicle. Um, we will also need some other tools. For example, we will use the Raspberry Pi board. This board has a microprocessor on top of it, and it's almost a computer. So we can use this for advanced communication with another laptop, which will do the processing of all the data which the vehicle is capturing, and that computer will also send instructions back to this vehicle to understand what the vehicle is looking through the camera which is mounted inside. And we will also use Arduino Uno board. Uh, right now we haven't decided whether we will use an Arduino Uno board, or maybe we use a smaller version which is an Arduino Nano board, because what this board or this board will do is, so these are basically microcontroller. They don't have a microprocessor on it, so they don't have any operating system. So they basically execute a set instructions that we code in them. So the function of this device on the vehicle will be quite rudimentary in nature. So it will, for example, tell the vehicle to either move forward or back, left or right. So it will just control the electronics, but it will not have any intelligence of its own. So it is possible that instead of using one large Uno board of Arduino, we may end up using maybe one or two of these small nano boards. So it will save a lot of space. So one example is that this will of course drive the motor. So there are two motors in this car, one at the back, which basically powers the rear wheels, and there is another motor at the front, which which basically steers this vehicle either left or right. So this small device, according to my assumption, should be able to control these two motors. But the problem is that the motors inside this large vehicle require a dedicated driver, because this is a low voltage and low current device, this Arduino board. So we need a device like this. This is L298N DC motor controller. What this device does is that it basically connects with this small nano board. It takes the low signal from nano, which goes here through wiring, and then it will drive the DC motors which are of high current rating. And the Arduino board will actually send a pulse width modulated signal to this controller, and then this controller can operate a motor even if the motor has a different voltage. So for example, this vehicle and even this vehicle, they come with a 9.6 volt nickel cadmium battery, whereas our Arduino board operates on a 5 volt power. So we can use two type of powers in the same vehicle, one to drive small electronics or digital electronics like these, and we will use the stock battery which came with this vehicle, which will power our motors and any other devices which came with the vehicle. So all the high current, high load devices will work from this controller. And what we are going to do next is, so this vehicle goes out of scene now, so we keep it as one side. For the moment, even the remotes are not required, so we keep them on one side. All the digital electronics will be used later, so we keep them on other side. And what we need to do now is to basically dismantle this vehicle and understand the internals of this vehicle. So next step, what we are going to do is we are going to remove the hood on the top first. Once we remove the hood, we will actually expose the entire chassis, and we will also expose all the internal wiring and all the mechanical parts. So let's start with that process now, and we will show you exactly what looks inside, and then I will explain you all the mechanical parts as well as existing wiring which comes with the vehicle, so that we understand it better before we start modifying it.